we can get better. What's your solution, right? How can we support you there? 15 years was small, is now almost big, especially when we look in the semiconductor world.
World population is growing. We need the same product, maybe in more volumes.
I've been surprised what the human hand can do.
And then we go with the best solution to our customers.
Hello and welcome on DIXIT. Today is a bit special as I have the pleasure of hosting this conversation on behalf of Outcast France. I'm Yana Rogers and I'm really happy today to be joined by Müge Meiller, Head of Product Management and Strategy, and Freek Bressers, Director of Sales EMEA at Nordson EFD. Thank you very much both for being here today.
It's a pleasure.
We often talk about innovation in billions, gigabytes or megawatts, but there is also an industry where everything happens at the scale of a micron, where a single job can make the difference between something that works and something that fails. You may know someone who wears a hearing aid, or perhaps you do yourself. That tiny device exists because a machine placed an incredibly small drop of glue in exactly the right place. That's Nordson EFD. So today we are diving into the world of precision, miniaturization, and the invisible technologies behind modern industry. Before we get into the technology, Müge, how did you end up in such a technical and industrial field? And maybe you can just talk about your past, your journey, your backgrounds.
Sure. So I'm an engineer. So basically, I've always worked in technical, technical work, but also in very different industries. I have experience in the defense. I did start in defense, which is a heavily, male-dominated and very cyclical industry. Then I worked in electric vehicles for batteries, right, when the hype was there. I worked in medical. So my education already has brought me into the technical industries, right? Yeah. And also there's a joy in, following the innovation, what's happening, because I think today is very exciting with AI and also all the automation happening because we are in automation, right? So it's really exciting to follow these trends and then also to be able to part of it, right? So that's a bit my story in a snapshot, let's say.
Yeah, and we can feel your excitement. Freek, some question for you. What is always the path you imagine?
So for me, right, so if you look where I came from, I started with the EFD almost now 16 years ago.
Yeah.
So I started with the EFD in a regional sales position as a commercial person. I moved to Nordson in different roles that I had, and I moved back a year ago. And the reason to move back is just like Müge was explaining, the mass of applications we do with customers, right? So it's a lot about miniaturization, but it's also a lot about various applications, various industries, right? We are in the medical field, electronic fields, food field, assembly work. We have partners in industrial dispensing, right? We are everywhere, and that's part of I think we like at EFD, and I think most of our colleagues would say that. That's why they work here. It's a beautiful environment to work in.
Good to hear that, you are working in a very good environment and we can feel that. When you were younger, and that for you both, did you ever imagine working with something so small, but with such a big impact? Because it has a really big impact.
I would say no, right? So for me, when I will look, right, when I was an engineer, because I'm also an engineer by heart, I was never good at the small stuff. I was more good at I would say, the definitions, the data, that kind of of my job. Throughout my sales positions, I was forced to be a lot more precise than I've ever been. So doing things, and if you look at visits we done, right? So I remember one of my first visits with EFD, we were looking at a manual dispensing activity, and a person said, "Oh, do you see the dot?" I said, "I don't see anything." And then you go with the microscope and you blow that out 500 times to look at the dot, and you're looking at a small dot from 300 microns, which is fascinating to look at, right? So, so the answer was no.
All right.
Yeah, I think
And
it's a
you,
great
Müge?
question because dispensing is a world of its own.
Yeah.
So I'm a materials engineer, and I was more looking at working with composites, aerospace. Whereas when you're not part of the dispensing and automation world, you don't know it. But actually, like our products are in every factory. But you need to be in production, right? You need to be in that world. And when you go into dispensing world, you realize that actually it touches all the industries. And precise dispensing, it touches a lot of electronics.
Yeah.
So it's almost all industries. But my answer is also no. But I'm so happy to be in this field, I would say.
And let's make it a little bit more personal. I mean, in everyday life, are you more a very precise person, or the kind who builds IKEA furniture, without reading the instruction, for example?
You can answer that one first.
So the IKEA furniture falls on the husbands, right? So
Oh, come on! Not only on husband.
Joking aside,
Yeah.
I think I'm a bit of both because, of course, you can look at the manual, but in real life, it's more about implementation. Right?
Yeah.
There's always a theory, and then there's always how it has to be implemented. So I am a more of an intuitive person, I have to say. I would start with my own intuition, but then I would look at the, let's say, data sheet or the instructions whenever necessary, just to be sure that I don't put the, wrong part, the left to the right or right to the left.
Yeah.
Because then you have to undo everything.
And I'm a little bit more also like Müge said, right? So if I build something for my IKEA, I will not use the manual, but also the dispensing applications we do with customers, right? There are certain parameters you need to be aware of. So that's data, right? So that's the data sheets, but the road, how to get there, the path to get to success is often different, right? So sometimes you need to look at things differently to get a better outcome. And that's often what we need to do. So a manual, unfortunately, is not always working in our field. So we really need to figure out solutions with the components that we have and with the equipment that we have.
I see. Yeah. All right. Okay, now we're going to tackle something that's called elevator pitch.
Exciting.
So a little challenge, but a fun challenge, right? We're going to keep it simple. If you had 30 seconds, how would you explain your company's, mission, purpose to someone who has never heard of it? So I'm going to count, and you're going to start, and you have 30 seconds to explain that. All right?
Each 30 seconds, right?
Yes.
So yeah, Nordson EFD is part of the Nordson organization, a global company. We focus on very precise and accurate dispensing of fluids in any field and industry possible. So it's not just adhesives, but it's assembly fluids. It could be anything that you could use in your day-to-day work. We are part of a very large group of customers, right? So we support electronics, we support semiconductors, up to electronics, anything possible in that field. And we have sites all across the world that are able to support you with dispensing needs.
Good.
Yeah.
That was good.
Yeah.
Your turn?
Nordson EFD is a very innovative company because we help innovate automation. We help automate very manual processes. So I would say innovative, contributing to sustainability, because we also have a product line which is on plastics, and there's a PPWR regulation coming in Europe, and we are working in having more than 35% of recycled plastic content. So we really also believe that not only we're in industry, but we also contribute to the future, right? Also our packaging, we're working on removing, if there are any heavy metals from packaging.
Yeah.
So innovative, sustainable, and always evolving with the industry. And also we have a good durability to changes, geopolitical changes, and anything that is evolving in the market, because we are a very long-standing company since 1903.
All right. So we're going to talk, about what you actually do and go a little bit further after that pitch and presentation. When you say micro dispensing, what are really what are we really talking about? If you could explain that a little bit more, and how small is small?
How small is small? That's a good question, right? And I think when you look in what we do, right, it's very difficult for people to understand because people want to dispense fluids. And when I started 50 years and where we are now, there's always been a push to go smaller and smaller.
Yeah.
So at this moment, what we can do really reliable and accurate over time is dots from about 120 microns. And then the next question probably is, well, Freek, what does it mean, 120 microns? It's about the average width of a hair, right? So that's the dots that we make. And most of our customers want that very accurate. So think about 99.99% accuracy. And it's not just putting the dot always correctly, same size, so putting it in the right place. And I think that's where the other part of the company steps in within EFDs, that we also have devices that ensure that the dot is always there where it should be. Because it's getting more and more difficult when it's that small to really understand, is the dot at the right place and is it that what the customer really wanted? So very small.
Very small.
Yeah.
Would you like to add something?
I think Freek has given a good idea of, this hair example is great. I think we can also talk about miniaturization, right? So if you think of the electronics now are in a smartwatch, I think Freek has one.
Yeah.
That is where we dispense, right?
Yeah.
So you can imagine how small it has to be.
You make an important distinction. You don't dispense medication.
Correct.
Right? But the fluid used to manufacture the devices. So you are not treating patients. You are making treatment possible.
Correct.
You are, let's say, the architect of the invisible. How do you define that role?
So I just want to add we do not dispense medication, but we do dispense reagents or diagnostic kits.
Okay.
We are able to dispense any fluid. It doesn't have to be only an adhesive, but we definitely do not do the therapy to the patient. It will always be the device, right? If the reagent has to be on the device, or if a vitamin pill has to be lubricated, and it does, right? So that the person can swallow it better. So those type of oils or reagents we do dispense, but never to the patient.
All right.
They're always one step below.
Okay.
If that makes sense.
Yeah, that makes sense. And back to the question, would you like to complement?
Yeah, and I think to the question, right? So we work a lot with our customers, right? So, and like you said, our customers are asking for smaller devices, right? We have a lot of customers that have devices that go inside of the body. You think about catheters, or even if you look certain pacemakers or certain connections that are inside the body. And also the overall, everything's getting smaller, but the problem is also getting more accurate. And people want to put more stuff onto the same surface. So if you look at a smartwatch, there's much more knowledge that's now in the smartwatch than it was maybe when you have like a digital watch from 10 years ago. And I think that's where we support our customers in having that knowledge to understand where to place those dots, to have it accurately, but also to help them with understanding, okay, how do you do it correctly and how do you do it sustainable for a long time? Because those are things that you can do it once, but most of our customers want to do it in high volume.
I see. At what point does a human hand simply stop being precise and off?
Oh, that's a great question, I would say.
And actually, that's a fun question also, because I've been surprised what the human hand can do.
Yeah.
We have a lot of customers where people do fantastic things with their hands. I couldn't do it, right? My hands are quite big and I'm never that accurate, but I've seen people really doing very accurate things with their hands with unbelievable accuracy. And independent if it's in Europe or in Asia or in the US, it's fantastic to see. But it's coming more and more to the point that I would say low volume things work. The more it becomes higher volume, we don't have enough of those people that really can do it. And I think that's the key thing then, where then the automation steps in to really want to produce what the human hand is doing, to make it work for a longer production run to make that done. But I think the human hand, for me, it's still fascinating what certain people can do with certain elements of their hands, how successful they are in doing that. I find that ever still fascinating to see, to be honest.
And if I could add more flavor to that, so watchmaking is a great example of that, right? There are some people who are really very experienced in what they do.
Yeah.
And we know that the robots still cannot do those wrist movements, right? But then when that person retires or when that person changes the shift and the other operator comes in, the quality of the work, not because the person does a different or reverse quality, but it changes. It's human, right? How we design is different, how we write is different. So because of that, automation comes into play, because with automation, you have the same output, the same consistent quality, and that's where you have the limit of the human hand. It is very important, and I agree with Freek, it's fascinating what we can do with it. But then if you think about industry, right? I mean, the world population is growing. We need the same product, maybe in more volumes, right? So output becomes important. And in these type of applications, it's very important. And you can also see in a factory, most of the time, the errors or the quality problems are coming from the human error.
Oh, interesting.
So you minimize that risk of having a stop of a production.
And I would add to that also, right? If you look at the challenges to automate a process like that, it's key, because when you do by hand, you're able to dispense, but you're also able to adjust when something is not correctly, right? So we're dispensing fluids. Fluids have viscosity changes, so they change over time. And we see people adjusting things, as they say, on the wire adjustments. If you automate, you cannot do that. So often for our customers, that's a completely different kind of challenge to have, because that person was able to do that on Monday and on Friday, but now when the machine does it, and I go like, oh, but we've never had that issue. Because now you need to think back and go like, okay, but what is the person compensating? And what does the machine need to do the same thing? And I think that's where we step in to help customers to understand that you can do it, but you need to think about certain parameters to have the good impact on your dispensing results.
And also we can say, right, a person who has only 2 hands.
Yeah.
He might have more hands.
Yeah.
That's just like
Absolutely. And is there one thing, let's say it's the most surprising thing you have, ever seen manufacturers thanks to your technology? If you think about that, is there something that made you think, I never imagined our work would end up there?
Oh, I have one.
Good.
10.
I'm curious.
That's a fantastic application, actually.
Yeah.
We have an application where they printed sushi with our products. And that was for use in space. And actually, I don't want to make a mistake with the name of the company, but one of the big companies in Japan, one of the big car companies, right? And they do a lot of outdoor activities. Their board of directors actually came and ate that sushi. So that was very meaningful to us. And he said it tasted good, but it goes into printable food, right?
Wow.
Which is amazing.
Yeah.
And another one could be, it is also going into printable parts for heart valves, right? So that also shows that it can help more and more people in the future. But yeah, we do definitely have a lot of applications which are
Fantastic.
unthinkable of.
Yeah.
And I think for me, right, the biggest thing is I worked, and that's always a couple of years ago, together with the university. They're working on the smallest camera that goes inside the human body, that goes into the vein to see. And it's fascinating because you look at how big is the camera itself, and our dot is like a very minute dot that goes on it. And just the way that the fact that a material like that ends up and looks at the body itself from the inside. Like, I'm a big movie fan. It's like unbelievable, right? It's almost a movie being made. You go inside the body and you see everything, and that's fantastic.
That's fantastic.
Yeah.
Oh, thank you. All right. For people watching us, I think you already gave some example from the beginning of that conversation, but let's keep it a little bit further. Where would they actually find your technology in their everyday life without even knowing it?
We have an opening sentence.
You could go forward. Yeah, you go forward. Yeah.
But for whole Nordson, not only Nordson EFD, we have this opening sentence in one of our presentation. You'll find Nordson anytime you open a cereal box, because they are, there's a DIXIT there, right? Anywhere you use your, anytime you use your car, okay? Because all of these car parts are being put together, glued together. Yeah. So there's also the assembly there. Anytime you touch your electronics, anywhere there's a PCB board, there are Nordson applications. We are putting those PCB boards. We are putting solder on those. Sometimes it's our own solder. And then anytime there's also medical applications, because as Freek has said, there's the catheters and catheters are very much used today in any type of operation, right? Pacemakers, any type of medical device assembly, and even medical parts with our assisted division. So anything you touch, probably in this room, we can find a lot of things where Nordson has assembled or touched.
Yeah, and I would add to Müge's point, but we've sit at places and we said, where do we touch? We touch everywhere. So also in book binding, that's a Nordson activity, right? Look at insulation materials. If you look at cans that you drink, we have application on those. So Nordson touches you truly every day. But like you said, people don't know the name because we supply to other people that supply the machines.
Yeah. But this is why it's good to give this example, and it helps a lot to understand better.
Everywhere where a fluid needs to be dispensed accurately, Nordson fits it.
All right. And Nordson EFD did start with jewelry bonding. I'm just looking at your necklace, right? So
Yeah.
we could have even been, on the person, right? Not even things that we touch.
Yes.
So
Okay. You are almost everywhere, right?
we are everywhere.
You are. Of course.
We are everywhere.
Okay. Okay, now we're going to zoom a little bit more. I mean, everyone talks about AI, right? We are in that AI world, the software revolution, which is, by the way. Do you think we underestimating what's happening on the industrial sides?
For my feeling currently, no, we're not, right? I think there's a lot of momentum in AI happening, and I see AI touching us daily, right? And also that customers ask us questions on what AI gave them as an answer on something, or like, I need to do this, will this work? So I also see our role as an advisor to our customers as saying maybe AI, a software tool came back with a solution, and that doesn't really always work in real life. So we're helping customers to go that. But if you see a data collection, for example, right, a lot of our customers are collecting more and more data to better understand their failure rate, to better understand what they need to improve. And they come back to us and say, okay, we figure out that if we have a different bond here or a different connection, we can get better. What's your solution, right? How can we support you there? And I think that's where we see more and more AI coming up. And if you think about it, the other side, what does AI mean for us, right? AI is in essence, it means a huge amount of power and data processing power that you need to have. Meaning that all data centers in the world need to rechange or need to be able to absorb all that energy. That's again where we have a lot of applications in the electronics field where we're helping our customers, right, to support that. So to have better connections, to have better data flows, because maybe not everybody knows it, but if you look at a fiber optic, for example, there's a lot of connections, a lot of adhesive that goes into a correct fiber optic connection where we are supporting. So we see that really in our day-to-day lives.
Yeah, and I think people focus more on what AI will do on jobs, but I think it should be more about focusing on how we can make AI work for us. AI is still learning. It makes a lot of mistakes, and although the reports or the analysis it does it looks professional, but I think it's the human experience and the human brain which makes a difference there, right? And that's the way we are trying to use it.
Yeah.
And I agree with Freek for traceability of whatever is being done in the in a factory, and also to see sometimes it really helps you if you make it work for you. It helps you make decisions faster, right? Rather than working with that data and all these big things, it just spurts out the results, and then that's where you can use your time to do other things. So that's, I think, the let's say the personal or professional use of it. What does Nordson EFD do? To Freek's point, we're very happy to take part in this business because we are helping with fiber optic cable bonding in data centers.
Yeah.
And that's something that is going to continue because more and more countries want to use it. You need more and more data centers. So we cannot underestimate it because it is coming, right? And it's already there, and it's just going to grow in amplitude.
Yeah, so I understand that for you, it's a real partner, right? And so it does help you to free your space to focus more on something meaningful and continue to push all those boundaries. I understand that. With data centers, 5G, advanced electronic, is technology also becoming a race for precision?
I think it is, right? Especially it's a race for miniaturization.
Yeah.
Understand what they build more in. It also has a change, right? Because in the past, cables were copper was the definition. Everybody had copper wires, and now you see the world changing because it needs to go quicker, right? Because there are negative elements in copper that fiber optics don't have. So now we need to change that infrastructure to support that. And I think there is where we really support that change. And I think what it is, the connectivity that people are looking for, helps us to really support our customers better, right? Because if you have a facility in Asia, you have a facility in the US, you want to do the same everywhere. I think again, there comes where we want to be repeatable and accurate and things. That's a good point for us.
That's it.
Oh,
Nothing.
Oh, I'm lucky for that one. That's good.
You work with batteries and advanced electronic across Europe. When you talk about reindustrialization, with my French accolade, semiconductor sovereignty, local production, does it actually depend on technologies like yours, even if no one sees them?
100%.
Yeah, I would say yes, 100%. Right, where we see we were playing a role in the past, we saw a lot of large factories moving to other places in the world. Now we see much more industry coming back, but much more on the high mix, low volume side. So people want to build different kind of products. It's mostly on the very high accuracy side, or it has critical materials that they want to keep in a certain region. There is in the world that's changed. There are a lot of reasons why you want to produce certain materials in certain regions, and we play a role in that. And that means also often smaller cells. So in the past, you had a factory that was like 100 or 200 meters long on different stations. Now we have people that just have a tabletop assembly where you put something on, you press start, and the system dispenses a few dots or does an AOI certification if something is correct. So absolutely, we're part of that, and we're seeing that with our customers to figure out where to place which projects, right? And we've always been part of the development of applications, and we now see we're doing more and more larger scales there.
Okay.
Yeah, I think Europe is looking for its place, right? I mean, industrialization has highly moved to Asia, we know that. And then obviously, Americas is also trying to hold a lot of what they have.
Yeah.
Europe in between is looking for its identity. I think what Europe is doing is keeping the high value applications. That's where you can add value. Otherwise, it's very difficult when you want to go into a price war, right? But then we also have customers who are actually building pilot lines for those customers in Asia, right? Because of the know-how they have, because of the experience they have, because Europe has the experience, right? It's just that maybe the market has changed and, geographically it has shifted, but there's still that know-how. And that's where line builders, OEMs, contract manufacturers still work globally. And that's the strength of our company because we are globally based. So we can start this project in Europe, which is for semiconductors, which is heavily in Asia, but we can continue to support the customers in Asia or in US or in Mexico or wherever it goes in the world.
All right, let's talk about future then now. We started with AI. Let's talk about robotic as well. And what next? You already work with thousands of robots, right? Are we seeing the disappearance of the human gesture, or is it just transformation?
So I think we did touch a bit on that. I would say like very specialized ones are difficult, but robotics are also going to a very specialized way too, right? I think that's anyway the target, a robot that can be in almost everything. And Nordson EFD has its own line of robots too. So we know a thing or two, I think, on robots. I think the most optimal way we see, at least in the industrial setup, it's robots working side by side with human. I don't see that disappearing 100%, maybe in a far future. Maybe yes, but that's where it's going. And obviously, whatever can be automated is being tried to automate it because it's about maximizing output, minimizing errors, and minimizing scrap.
Yeah, I would support that, right? I think when you look at the role of robots, I started long time ago with a robot company, and at that moment people were saying, "Oh, robots will take over everything." We're not there yet, and I don't see us getting there, right? Everything's getting better and more accurate and more precise, but you still need the human touch. And especially if you look at where we're also involved in more the pre-development of things, that's still a very much human kind of interface of it, right? And that depends heavily on how do you do it, how do people do it, how does it feel, how can you connect those certain parts together? I don't see robots stepping into that world, right? So I think when you talk about the assembly process itself, I would see more robotics and more automation coming into play.
Yeah.
But initially that first step, we need humans more than ever, right? Because innovation is thinking. It's not moving something from A to B. It's how do you do the same thing differently?
Yeah.
And I think that's really where people started.
And in a factory today, what costs more? You were talking about trying to reduce or minimize error. I mean, what costs more, a machine breaking down or a precision error?
So I think definitely a line down is a big thing, because imagine you have your resources well spread.
Yeah.
All the resources will go down.
Yeah.
That's time not spent producing for anyone,
Mm.
right? And then if it's a repetitive line down, that's a big cost. And that's when our customers come in. They sometimes forget to contact us from the beginning, where we could have already helped them.
Yeah.
But we also help them sometimes, most of the time, right? Correct those automation decisions, right? Maybe they have put a dispensing system which was not meant for that fluid, or which was not meant for that speed, cycle time. So that's where the know-how is really important. But I would say a line down definitely costs a lot, but also the scrap rate, right?
Mm.
So if you are making faulty parts, that's a big thing too.
Yeah, and I would agree with that. But I think the line down versus dispensing error, a lot of our customers use advanced electronics, right, or optics to understand, is the dispense at the right place, yes or no. So to Müge's point, right, that's scrap at that moment. So machine keeps on running, but it creates scrap in the end. So customers don't want that. Line down will have bigger issues. I think when you look at how the development is going with lines downs, and also how dispensing is part of the eco flow of a system that we support there, I think you see much more unexpected lines down, and you will see dispensing errors on a more stable process. I think when you're trialing out, that's not the case, but when the process is stable, I think I wouldn't expect that much dispensing issues overall.
All right. A bad drop of glue means a rejected component, a medical device sent to waste. Is precision ultimately the best ally of industrial ecology?
I would say yes. I would say
It's our philosophy.
high quality, right? High quality dispensing is key, right? Because we don't want our customers to create scrap, not because it's not our vision to create scrap, but we want to have high quality products for them also, right? So.
And I think maybe we didn't go through our journey, but to come to that precision dispensing, we have actually labs all over the world where our engineers first test those fluids, right? If you are dispensing a cyanoacrylate, like a super glue type of glue, or if it's another epoxy time, first they look at the viscosity, how that fluid flows, and then they look at the cycle time needed, because some factories want 3 seconds for a cycle time, some want maybe 20 seconds. So there is an engineering work going behind that, and then we go with the best solution to our customers. So to have that precision, there is also brain power, know-how, expertise going in. So for us, it's very important to be able to be there.
Okay. When you look ahead, what impresses you the most? AI, robotic, miniaturization, or simply the speed of change?
For me, it really is miniaturization. Right?
Yeah.
So I've been in the industry now for 50 years. What 15 years was small is now almost big, especially when you look in the semiconductor world. Right? That world has completely shifted and changed. If you look just at any mobile device that you have, if it's your phone or it's your smartwatch, the amount of functionality it has now versus what it had, that's all part of the change, right? And to make that change, you need to have new functionalities on your PCB board or in your device, or more cameras, right? Multiple devices have multiple cameras inside. To make that happen, you need to dispense. That's why we fit in. And for me, that's the most fascinating of it. So for me, it's miniaturization.
To me, it's the speed of change. I think as consumers, we become spoiled. From the first Nokia, where we had the snake game, and now we just expect that perfect change, right? I mean, we expect the smartphone to have the new model every 2 years, whereas before had to be durable, make the call, and maybe have to gain that, right? So from where we come from where we came from in these 90s, I think it's really the speed of change, how the consumer expects things to get smaller and then more innovative. And even with AI, I think that's going to change even more.
Yeah.
Right.
Wow, that's a fantastic conversation. And I really enjoy it. I say it because it's already almost the end of that conversation. So That's very passionating. I have a last question for you. If you could go back to one moment in your career or your life to change something or to do things differently, what would it be?
I don't know if I would change anything because that's why I'm sitting here today, even the mistake.
And we are glad that you are sitting here because that conversation is fantastic.
And I would add on to Müge. Right? I'm also not a person to look at mistakes or things we've done, we should have done differently, right? I'm much more a person that looks forward. I think every mistake you've done will form you going forward.
True.
So I'm less concerned of what happened and more what I'm going to change tomorrow. Right. So I think also in the role we're in.
So you're more forward thinking.
Forward thinking. You can change every day, right? So even if you did something bad today, you can change it tomorrow, right? And one step ahead, I think there's always positivity there.
And whoever doesn't do anything won't make mistakes, right?
Wow.
Yeah, that's a quote.
That's a fantastic way of, ending a conversation. I couldn't expect more than that. Thank you very much. Thank you for that conversation. It's so fascinating to see how something so small can power something so big. So thank you. It was a pleasure. It went so fast. And I think probably we could have talked much more. But thank you again. Thank you for being with us today. Thank you to everyone watching DIXIT. So don't hesitate to watch the full interview on DIXIT and see you very soon for another and new fantastic conversation. Bye-bye.